Thank you for the organisers for inviting me to talk about this topic, which I feel very passionate about, and of the many projects I'm doing, this particular project is one of the most exciting as a scientist, because often we're just stuck in the lab and we're working on tissues or in isolation, but it's the study where we've directly impacted the outcomes of the women who've volunteered for the study. So it's very satisfying as a scientist to have some direct contact with clinical outcomes. So just a bit of background to genetic testing. Well, what is it? Well, what we are planning to do, what we want to do, is to screen women and men as well, the population, for genetics, for mutations which you inherit, which increase your risk of cancer, in this case, breast cancer. And so David Lane was talking about that before. A certain percentage of the population have an increased risk, or a much higher increased risk of developing a cancer than other people. So can we identify those individuals before they get the cancer? And the reason we're working on breast cancer and also ovarian cancer is that there's a relatively small number of genes that account for a large proportion of the inherited risk for breast cancer. And you all would have heard of genes BRCA1 and BRCA2. They don't account for all those inherited cancers, but they do account for a large proportion. So if you're screening for those inherited risks, you don't have to screen that many genes. Now, importantly, you don't want to be screening for an inherited risk of something if you can't do anything about it. What's the point of that? But importantly, with breast cancer and many other cancers, if you know that you have that risk, there are very effective ways of either screening to detect the cancer earlier, or there are prophylactic measures that you can undertake. Some of those are very radical, mastectomies and other sort of surgical means. But you can actually reduce the risk down to less than the population risk if you have a very high risk of that cancer. So if you identify people, you can do something about it. But unfortunately, traditionally, how do we identify an individual who has a very high inherited risk of cancer? Well, it's normally based on family history. And so what happens is that an individual will develop cancer, and then their oncologist will take a family history, or there'll be something about that cancer which triggers them thinking that this looks more like it's genetic. There's something going on in this family. And so they will then be referred to a familial cancer centre, who will then look at the pedigree and then decide whether to do genetic testing. Now, there's two problems with that. One is that means one person in that family has to get cancer before you can identify that carrier or that family. But in particular, a large proportion of women who actually develop a breast or ovarian cancer don't have a significant family history. So they have a mutation in BRCA1 and BRCA2, but if you ask them, have you got a family history, they say no. And often you look at their family history, and they don't actually have any particular family history. Now, often that's because they don't know the family history. Like myself, beyond my brothers and sisters, I really wouldn't know whether there was any cancer in the family. And genes such as BRCA1 and 2 predominantly affect women. It could be inherited through men, but predominantly women get the cancer. So if you have a family that's dominated by lots of male siblings and cousins, you won't necessarily see that family history. So there's big problems with the way that we currently identify these women who are at very high risk of developing cancer. So people have thought about, well, let's just screen everybody. Let's don't worry about waiting for somebody to get cancer. Let's just screen everyone. And so people have done that for some populations. In particular, they've done it for these Ashkenazi Jewish populations. And this is really for technological reasons, and also some of these groups have a much higher frequency of carrying these mutations. I think David talked about these founder mutations. So 2 or 3% of Ashkenazi Jewish populations will have a mutation in BRCA1 and BRCA2. So they're a very good population to test the idea of just screening the healthy population. And so from the small studies that have been done, it's shown that the health economic benefits seem favourable, the health benefits are favourable, and seem to be well accepted by the population. But these are very specific populations, and will that be applicable to other populations where the risk is not perhaps so high, the prevalence of mutation is not so high? Second, and we know the frequency in these populations, but what's the frequency in other populations? So in Western Europeans, there's only been one study that I'm aware of looking at 1,500 women, and they found a low frequency of mutations in these genes in healthy women, but they didn't report that information back to those participants. So the question is, would these women have welcomed to get that particular result out of the blue? And so they're the sort of things that we want to address. And so we kind of think that this is an opportunity now to embark on this exercise, because the technology now is such that it's becoming very cost effective to sequence on a large scale. And for example, I don't know, maybe some women here have had a BRCA1 or 2 test, and if that was like 5-10 years ago, it would cost maybe $5,000 Australian or New Zealand dollars to do a test for one gene. We can now do in the laboratory just for a few $100s. We can screen dozens and dozens of genes, and very, very quickly. So the technology is to do this on large scale is already there, and it's going to get cheaper and cheaper. And also for these breast cancer genes, there's a large database of mutations. Now, obviously, we all have differences in our genetic makeup, and you have to interpret that. And so you might have a particular difference in your genetic makeup in a particular gene, but what does that actually mean? So it's very hard to interpret for most genes, but for the breast cancer genes, we've been looking at this gene for a long time. So we're fairly sure that we can see a particular change in that in that gene, that we're fairly sure whether that's actually going to be causing cancer or not. And also, I think in general, people are becoming, certainly in the Western countries, are becoming more aware of genetic screening. Many women are actually opting to pay for these screening tests themselves, but worryingly, they do it in the absence of proper counselling. And again, as I think as David Lane mentioned, public awareness of risk. I guess all of us, we're very poor at actually sort of balancing the risk of something. And so if you get a genetic test, in the absence of getting some advice on what does it actually mean for you, it can be very, can have very bad consequences. So the aim of this study was to, first of all, to see how many women of healthy women in the general population carrying a clinically actionable mutation in a set of genes that we know predispose at high level to breast and ovarian cancer. Also, what proportion of those women would have been detected anyway, because a family member would have developed cancer at some particular point. But also, importantly, how acceptable to these participants is it to get a letter saying, when you've got no family history, no personal history, and say, you have a mutation, you have a 60% chance of getting breast cancer in the next 20 years. And also, what are the clinical outcomes? So once you give that information, do the women actually do anything about it? There's no point knowing your risk if they don't take any particular action. So the resource that we used was a cohort run from the Peter Mac called Lifepool cohort, and these are women who've been recruited, who are participants in the population-based mammographic screening program in Australia, and we've used one from Victoria. Average age is 60, and it's potentially an issue. I'll talk about that later. And importantly, we have a two-stage consent. We consent them to enter into this study where we're looking at mammographic screening and ways to improve that, but also we want to do genetic research. So women who recruit into this study, once they're recruited into there, we ask them if they would then be willing to donate a DNA sample for genetic research. And so, and 3/4 of women will say yes to that. And importantly, this genetic research, we do say very, very specifically, if we identify something that has clinical implications for you or family members, we will report that back to you. So the women are aware that, so they may be sent a result at some particular point. So we screened just under 6,000 women, and we're planning to do 15,000 women by March next year. This is the age. And importantly, all the women were cancer-free at time of their DNA collection. And we screened them for these 11 genes, which are these hereditary breast and ovarian cancer panel genes. These genes are well-known breast cancer genes. Others cause other cancer syndromes, including breast cancer. And we also included some genes that are predominantly predisposed to ovarian cancer. And I won't go into techniques of the sequencing. Now, so when we looked at that particular data in the lab, we are able to identify what we think are changes in the gene which are going to be pathogenic, which are going to predispose to breast cancer. And we do a number of ways that we can identify that. But then importantly, we then pass the information on to the experts in the Familial Cancer Centre at the Peter Mac to get their expert advice as to whether that mutation would really be actionable. So if that woman came into the clinic and she had that result, would they action that mutation? And once we have their go-ahead, the next step is we then will send a letter to that participant informing of that result. So this is sort of summarises several years' work in one table here. And I just want to highlight up here. These are the genes that we reported on. So we've looked at other genes, but these are the genes that we've screened. And importantly, so the numbers that we look at here is that out of these almost 6,000 women, we found 38 women who had clearly pathogenic mutations in these genes. And so they are at very high personal risk of developing breast and or ovarian cancer. So about 0.64%. Some of the other genes, we didn't find any mutations. These ovarian cancer genes, we found another 0.25% of those women who have mutations in these particular genes here. But at this point, we've only reported back for the breast cancer genes. So this is important information that coming up to about 1% of this population will have actionable mutations in these genes and without them ever having cancer at this particular point. So how do we report this back? So first of all, we only reported back clinically actionable results. We didn't report back to the women if we didn't find anything. And now we may or may not do that in the future, but that's all we did at this particular point. We didn't report back if there was information where we're not quite sure what this mutation means. We only want to send back results where we're clearly there was something actionable. So Lifepool then sends a letter to this woman saying that there might be something that's potentially clinically actionable, and we then give them details of a phone number. One, they can either contact the Familial Cancer Centre and make an appointment themselves, or as a first point of call, they can call this telephone genetic counselling service, where they can get some information on what that result might mean. So what they do is they tell them about the broad implications of the result. They'll give them any psychological support that they need, and they'll then also help them to navigate through the process of how to get an appointment. Now, importantly, once a woman from this study has booked an appointment at the Familial Cancer Centre, she then follows the standard care. So no different to anybody who's been recruited through the normal route, being referred because the family members has cancer. Okay, so the genetic counselling process is quite detailed, and a number of centres, in particular I think in New Zealand as well, we have this sort of process where women can call up at any time. And it's important that, those counsellors are very experienced at helping the women to cope with what could be a very distressing result and important implications for their lives. So they do a very, very good job of counselling those women, and that is reflected in a very high uptake rate. So most of our women eventually opted to get referred to a familial cancer centre. So how did women respond to receiving this letter? Well, currently we have, out of the 35 women who we sent a letter to, so there's a few that we still need to send the letter out because this data is just ongoing. We had 32 of them have contacted the telephone genetic counselling service, and I think 2 or 3 of those we perhaps have lost contact because we did recruit these women a number of years ago. So a high proportion of women contacted a telephone genetic counselling service, and most of the women contacted very quickly. So most of them was like just a day after. The range was 1 to 49 days. So they relatively quickly from receiving this letter called the telephone genetic counselling service. And all but one of these 32 women did go on to attend a familial cancer centre, except for one who actually got diagnosed with cancer between us informing them of the result and us doing the sequencing and informing of that result. So overall, the response rate was very, very encouraging. And then once they were referred to a familial cancer centre, well, what did they do about it? So far, and again, this is ongoing work, so we haven't got data for everybody, but we have information available for 13 of these individuals, and so far, half of those women have undergone a surgical risk management. So they've had their ovaries removed to reduce the ovarian cancer risk. And then obviously once you identify one individual, so when you go screening the population, you're not really identifying that individual, you're identifying the family. And so once one family member is identified, then often other family members will then happy to be recruited. There's been, of the 19 families where we've been able to contact other family members, we've had 63 relatives. So of these 19 index cases that we identified, 63 relatives are attending an FCC. So in general, for every one individual we pick up from the population screening, we're getting about 3.3 relatives. So you're amplifying the effectiveness of that screening. And so that's actually about the same as we'd get if a woman has come in through the traditional approach. And of these 63 relatives, half of them have tested positive for BRCA1 or 2 mutation. Okay, so the next question is, well, how many of those women would have been referred anyway? And so looking here at of the women, we've got the data of these 38 women, only half of them had a first-degree relative with breast ovarian cancer. Remember, none of them had a personal history of breast ovarian cancer. A couple of them, interesting, had previously attended an FCC, but for some reason hadn't been offered genetic testing. And importantly, in Australia and many countries, there's this risk score that's calculated, Boadicea score, where it's the risk, it's kind of to get paid, for the government to pay for it. They have to meet a certain sort of risk threshold for being a carrier of mutation, so it's greater than 10%. And of all these women who tested positive from our screening, only one of them would have been offered testing based on that particular score. So the vast majority of the women would never have met the criteria for testing for those mutations. And then obviously worryingly, because this was a research study and we collect these women for a number of reasons, actually a number of the women actually developed cancer since we collected the DNA, which was unfortunate, but that's, I'll discuss that at the very end. Now in terms of the feedback, the women fell into 2 classes. The women who, there were some women who had a bit of a family history, or those who didn't. And so the women who didn't have any family history, this was a typical response. They found it was very confronting. They couldn't believe it, surreal. They thought maybe we got it wrong, never heard of the gene. So really they were very surprised at the result and sort of couldn't really believe what was happening to them. On the other hand, there were women who had, maybe had there was a few women who had perhaps a relative with ovarian cancer in particular, and they donated the sample and they got the letter, so a bit surprised, but I knew exactly what it was. They kind of were expecting there was something going on in the family. So they fell into those 2 camps, but importantly, we've contacted some of those women. None of the women regretted being in the study. So obviously it's very confronting to get that result, but none of them said, oh, I wish I hadn't been in this particular study. And that, I think it's reflecting the fact that essentially all the women went on to the FCC and have done something to reduce their risk. And then as a scientist, it was very encouraging, where there was one woman who just out of the blue contacted my laboratory with telling about her journey, and we found a mutation, and she found she had some precursor lesion in her breast, and she's doing okay. And this was very encouraging. Thank you, you've saved my life. So that was very encouraging. I think that was sort of typical of the response that we had. So the summary then is that, to my knowledge, this is the first study where the population has been screened for germline mutations, so inherited mutations, in a cancer-free population from Western European group. And also it's the first where it's been communicated back to the participants. And we're finding sort of this 0.5% to 1% of women will have actionable mutations in these high-risk breast cancer genes. Now, importantly, we're just looking at a few genes here. There are lots of other cancer syndromes, and so there's no particular reason why we couldn't be adding other genes in here. There's no reason why we couldn't be adding men to this, because men can also inherit these genes, and so they don't necessarily get the breast cancer, but we could screen them for these genes as well. That would be another way of identifying the family. Now, as I mentioned, the women in this study were from mammographic screening, so the average age was 60. And in fact, if you carry a BRCA1 or BRCA2 mutation, the peak time for getting a cancer, when they start getting cancer, is in the 40s and 50s. So in fact, it could be many of the participants in our study may have already had breast cancer, and therefore they're not eligible to go to the screening. So we believe that this number is actually, could well be much higher than this 0.64%, so maybe up to 1% or so. So that has implications for how we design a future study. And importantly, the majority of women had an unremarkable family history of cancer, but despite that, there was a high uptake of the diagnostic testing. We found that the women who are recruited in this way responded and in terms of taking preventative action and other family members was similar to whether they were recruited via traditional approaches. And as I mentioned, where the plans is to do up to 15,000 women, and part of that study is to do more detailed health economics, to say, how much money do we save, how many lives have we saved in this process, and to more formally consult with the participants to see how do they understand the experience, how could it be improved. So overall then, a relatively high proportion of the cancer population carry these mutations. Most women would not have been referred through traditional approaches, and very important, it was a big worry, despite the absence of any personal family history, we showed that this was well accepted, and these women were really no different to those women who are recruited in the regular way. So the question is this just a research study? Where's this going to head? So will this ever become a reality? I certainly believe yes, it will be. And if I was going to take a bet, I'd say within the next 3 to 5 years, in some countries, this will become a reality. Certainly, I know in other countries they're doing similar studies. They've not reported that on yet, so it's in a research setting. But I think, again, as David mentioned, many women are now, and a lot of centres are actually sequencing people who've got cancer in the hospital. They sequence them up front. Other women are just getting a sequence done on their own. So I think there's a great public willingness to participate in this. So I believe next to 3 to 5 years, this will be a reality. But there are a number of issues that need to be resolved. So first of all, when to screen. Clearly, 60 is too old because we will be missing many of the women because they will get the cancer younger. This is just a convenient set of women. So potentially what we'd say when to screen, maybe age 30, because if you're a carrier of those mutations, it's very rare that you would get a cancer under the age of 30. And that also would be, if you knew you were a carrier, then it gives you plenty of time to think about your options. If you haven't had children yet, there's certain lifestyle choices that you might want to make if you can get that mutation test earlier. What's the mode of recruitment? We've used breast screen, but potentially I would think maybe through a GP clinic. You would just advertise in a GP clinic that you can have this test, and the result would go back to the GP, and then you would get referred to an FCC. The other important thing is that how do you provide adequate informed consent on a population basis? Individuals will come into a familial cancer centre and you can spend half an hour talking about what are the implications of having this test, whether it's insurance or other things. But if you're going to be screening hundreds of thousands of people, how can you do that in a cost-effective way? Will a letter be enough? Will a website be enough? So we need to be testing these sorts of things. And also, should other hereditary conditions be screened as well? And certainly you could be doing colorectal cancer, prostate cancer, and maybe non-cancer conditions while you're doing it at the same time. So that could help to make the whole process more economically viable. And of course, we need to know how much will it cost and how much will it save, and that's obviously very important if we're to convince sort of the government agencies to fund this particular study. But I think it's not a question of if this will happen, it's just when, and I think it's going to be, well, I'll be hoping sort of within my research career in the next sort of 3 to 5 years. Thank you.